Hi guys, today we will be discussing about the double slit experiment. The double slit experiment was carried out by Thomas Young in 1803. This was the first experiment which shows the clear evidence of the wave nature of light. We had the theory of Newton, which was the particle nature that existed before. We can see two slits here and a screen. If it was particle nature, we can only see two patterns which are here and here when you send a particle through these two slits here. But as we send light, we can see the wave nature and we can see a pattern similar to this. So we would have a similar pattern here on the screen with equal gaps in between. This could go from minus infinity to plus infinity, or till light can exist in a particular region from here to here. Now we will consider how these particular patterns are formed on the screen when we pass the array of light from this end through the particular two slits. This is only because of the interference patterns we have discussed. When two waves travel, there could be constructive interference and destructive interference when they coincide with each other. When two waves having the same wave nature and which are traveling in the same direction interfere, we can see constructive interference and the wave eventually becomes a wave with a higher amplitude. But when there are two waves which are coinciding in two different directions, we can see there would be a wave pattern similar to this. This is called the destructive interference. Now let us see how the patterns are formed by the two slits. We can see plane wave fronts travel in this direction when the light is introduced. And after diffraction, those two light beams are traveling in wave fronts similar to this and similar to this. At instances like here, here and here, and also in these particular areas, we can see interference patterns due to the interference of the two wave fronts traveling from the two different slits. So we can see a bright spot at these areas where there are black dots. We can also see dark spots in between them. This is because of destructive interference. And the bright spots are due to constructive interference of this particular array dots. These are also known as fringes when it comes to the double slit experiment. When we consider the double slit experiment, we can see two slits like this. And the separation in between the slits are simple d, and the separation between the screen and the two slits is capital D. When a light ray travels from one slit, gets interfered with the light ray traveling from the other slit, we can see a pattern on the screen. This could be a dark or bright fringe. As we can see, we can enlarge the triangle here and we can obtain a triangle similar to this, where d would be the separation of the slits and theta would be the angle of separation from one fringe to the other. So when constructive interference occurs, we can see the formula d sin theta equals n lambda, as destructive interference forms d sin theta is equal to n plus half lambda, where n is an integer. So when an integer is present, you can see that n could be 0 to plus infinity, but only in the range of 1, 2, 3, 4 and so on. This cannot be 2.3, 3.8 because those are integer numbers. As we discussed, we can see that the constructive interference is equal to d sin theta equals n lambda and the destructive interference is equal to d sin theta equals n plus half lambda. When we plot the intensity versus angle theta, we can see there would be a maximum points and also minimum points. The first peak point here is called the central maximum. This occurs in between the screen where the two slits meet at the central position. This is the first dark fringe, this is the first bright fringe, and this occurs at either sides of the screen of the two slits. We know that lambda is really small than the separation of the two slits. This is because lambda is in nanometer scale, and hence we can see that theta is also small. When the theta is a small angle, from basic rules we know that theta is equal to or approximately equal to tan theta is approximately equal to sin theta. So the sin theta in this situation becomes simple y over capital D, where simple y is the distance in between one's fringe, whereas D is the separation in between the screen and the slits. So from this we can obtain that y is equal to D times sin theta. And from the previous equation we can substitute the equations and find that y is also equal to n lambda over simple D times capital D. This equation can be used for calculations with regard to double slit experiment. So this is it for today guys. Thank you for listening.